logic gates. We will see the logic gates application. So before seeing this logic gate, we will see where this logic gates are applied in our day-to-day life. Let us consider the simple example. So here we are using boiler. Suppose we want to on the boiler. Here they are given the condition. If chimney is not blocked and the house is cold and the pilot light is lit, then open the main fuel valve to start the boiler. So we can take it as B is a chimney blocked, C is house is cold, and P is a pilot light lit. V is the open fuel valve. So the given statement is if chimney is not blocked and the house is cold and the pilot light is lit, then open the main fuel valve to start the boiler. So based on this statement, we can write the expression. So we open when boiler valve to start boil, V is equal to chimney is blocked. So chimney is blocked, we can write not B. And house is cold and pilot light is lit. So this is the way we can write the expression V is equal to not B and C and B. So this expression we can write it in the form of, we can draw the expression in the form of logic diagram. So chimney is blocked. So chimney is blocked, it means not. So we are using the not inverter. So the and C, then it is given B bar, C and P. So we can use the AND gate. So it is a simple example. So we can write any real-time statement or real-time application in the form of Boolean expression. So using the Boolean simplification, we can minimize the expression and we can use the AND gate based upon the expression. Why we are reducing the expression? So if we didn't reduce the expression, we require more number of gates. So Boolean reduction is important. If we reduce the expression, you will get a simplified expression. You can use a minimum hardware. So it will reduce the cost. So the logic gates are very, very important in our day-to-day life. In our home, we are using a lot of applications using this logic gates. So any controller, microcontroller or microprocessor, everything will have a logic gates. The microcontroller, for example, any memory chip, let us consider microcontroller have memories. It will have a memory. Memory means it's a group of flip-flops. The flip-flops contain only the logic gates. So each and every electronics project you cannot see without this logic gates. Let us take this washing machine. The washing machine, it is an embedded. The embedded system is nothing but completely designed by using this logic gates. So we'll see our real-time application. Before seeing this real-time application, I'll let you know that we have 7 types of basic logic gates: AND, OR, exclusive OR, NAND, NOR, exclusive NOR, and NOT. These are the important digital devices. So when we talk about this real-time application, we will see simple examples. So you can try it also at your home. So push button lock. You can create push button lock, light activated burglar alarm, safety thermostat. These are the some of the example you can develop by your own. Okay, so nowadays you can see any communication without logic operation, you cannot communicate anywhere else. So the logic gates are very, very important in our day-to-day life. So we'll see one by one. So let us consider OR gate. So first we'll see the OR gate truth table. Let us consider two input A, B, output is Y, right? So if when you will get the OR output, if any one of the input is high, you will get the high output. Okay. So here in the industrial plant, we can let us consider two sensors they are using. One is temperature sensor, another one is pressure sensor. The temperature sensor is the input of the one comparator. Similarly, the pressure sensor output is input of the another comparator. Here the comparator will have a reference. The comparator, suppose let us take the temperature comparator. Temperature comparator compare with the reference level. If the reference level is higher, then it will give the input 1 to the OR gate. Similarly, if the pressure sensor is based on the pressure sensor level, so the comparator will verify with the reference. If it is high, then it will give the 1. So if it is 1, if both the inputs are both the OR gate input is 1, then the OR gate output is also 1, then it will give the command to the plant, shut down the plant. Or if any one of the sensors more than the reference value, these comparator will give output as 1, then any one of the input of this OR gate is 1, then the output is 1, and automatically the plant will shut down. So the simple OR gate will help more, right? Next we'll see the same and OR gate. We can use it in our home for door alarm. So you can fix the sensor in all your doors. If any one doors open, automatically your input is 1. Any one is on, then your input is 1. Then automatically your OR output is 1. Then you will get alarm signals. All the doors are closed, then your OR gate produces 0. Then you will not get alarm. You can try at home itself. So next we will see the AND gate. AND gate, 2 inputs and 1 output. So 2 input. If both the inputs are high, then only you will get the output high. So you can use this AND gate for your burglar alarm at your home. You can place one switch inside, alarm switch is always on. Then person sensor is outside. If the any one person enter into your near the door, then the person sensor will get on. Then both the sensors outputs are high, where AND gate input is high, then automatically burglar will alarm or on. So that way you can protect your home. Similarly, here the push button. Here 2 solenoid gates are there, A, B. If both are contact, then the lock will be automatically open. If any one of the keys on, it will not open. So if you require or either open or lock or door or anything, you can use this AND gate. Next we will see the NAND gate. The NAND gate truth table, input, 2 inputs and 1 output. The NAND gate and with the inverter is called the NAND gate. So if any one or both the inputs are 0, you will get high output. For both the inputs are high, your output will be 0. So you can use this NAND gate for any quiz, or you can the buzzer, using as a buzzer, right? So if both the person pressed, let us consider this and with the not, for both the person pressed high, then the buzzer or light will not glow. Any one person, say you can any one person press the button, then your light or alarm will, buzzer will glow. So that way you can use this NAND gate for your application. Similarly, this automatic watering system. The automatic watering systems, you can use it automatically. If the soil is dry, then automatically the pump will get started. So you can try this for your field. So now let's see the NOR gate. So NOR gate, if both the inputs are low, then only your output is high. So you can see here the mixing tank. Here 3 tanks are there. 3 ingredients are there in the tank. It is connected with sensors. Once the sensors closed means you are getting 0 input in your NOR gate, then your output is high, right? So if the sensors gives 0 value, then sensor 0 closed, then your input of the NOR gate is all are 0, then automatically your NOR output is high. Then this power converter mix the mix the tank using this mixer. So you will get the output. Similarly, exclusive OR gate. The exclusive OR gate inputs are 2 inputs and 1 output. So here the exclusive OR, any one of the input is high, you will get high output. If both the inputs are same, you will not get the output. So you can use this exclusive OR for the game show buzzer. Okay. So exclusive OR is nothing but if both the inputs are high or low, you will get your output. So you can use this based on this truth table. You can, wherever you want, you can use it. Suppose here you can take this example. Here both should be suppose both the levels high. It should not go for high or it should not go for low, right? Either it should be in both should be high or both should be low. Then you will get a alarm, right? So there you can for that case you can use this exclusive OR. So a lot of applications are there. You also try at home. Thank you.